Well, hello, ladies and gentlemen. Welcome back. Another installment of Making Stuff with Mr. Yurko, or whatever you want to call it. So, welcome today. We're going to be taking a look at cookie cutters. Everybody loves cookies. Cookies are delicious. I love cookies. I'm not even allowed to eat cookies because I've got a wheat allergy. But that doesn't mean I don't like making cookies. And there's awesome cookies out there, even for people like me with bad guts. So today we're going to go ahead and make our own, we're going to start the design process for designing our own custom cookie cutters. So here we have a sketch of a cookie cutter that I am developing. This one is for a gingerbread man. You can see that I've got my oblique sketch, my multi-view sketch showing the front, top, and right side of my cookie cutter. And you're going to be producing some similar things. So your question, of course, is what the heck do I want you to do today? Well, what I want you to do today is go ahead and get this right here. Is go ahead and concept sketch, research your ideas. You're going to produce at least 4 different ideas. Go ahead and search your Google and interwebs and ask your friends across the internet uh, what kind of cookie cutters that they might be interested in, what kind of uses you're going to need them for. Figure out where, when, how, why you're going to use these cookie cutters, and you're going to start sketching them out. Great concept sketches. You don't have to be spectacular sketches, but get the point across. Okay. You want at least 4 different cutters because not all of them are going to work. We're going to make sure that they are a 3D printable design. Remember that 3D printers lay material on the machine using basically a giant hot glue gun. Actually, not a giant hot glue gun, but a robotic hot glue gun. And what will happen is we start at the bottom. We just layer the material on, going back and forth, back and forth. Each layer, the tip gets a little bit higher, layering the material up. So we build from the bottom up. So this is a 3D printed part. It's 3D printable. This is a 3D printable part so long as we put it in this orientation so that the hollow portion is up. If we flip it over, it's no longer a 3D printable portion because we have that big overhang. Elephant here is 3D printable because every part of the print is supported by material under it. Even this trunk and these ears are supported because there's just the overhang as you climb up is really small. So there's constantly layers of material supporting it. You don't have any material sticking straight out in this particular build. So we're going to make your cookie cutters. Your cookie cutters will be something like that when it's all said and done. They'll have an outline. You can include a back on it, like this one here, if you want, that has a closed back so that you could have internal details. So if I wanted to make a wheel-like cookie cutter, so that I pushed down so that there was a round feature with a dot in the middle, something like this could be produced. So go ahead and have fun with it. Try your different designs. And you're looking at least 4 different designs. They need to be 3D printable. We're going to have to be able to model these using our Onshape system. And as far as size goes, they need to be between 2 inches and 4 inches. What the heck does that look like? What that looks like is that the minimum size is 2 inches and the maximum size is 4 inches. So it's got to be at least as big as a 2-inch box. It doesn't necessarily have to fill the entire 2-inch box, but its minimum width and minimum height are 2 inches. Its maximum height and maximum width are 4 inches. So what the heck are we going to get out of this project? Why are we going to do this? What in the world is the point? Well, we're going to improve our modeling skills. We're going to get better at that. We're going to get better at our problem solving. We're going to improve our math skills, and everybody loves math. And there will be a final product when done. It's going to be a really cool cookie cutter, your personalized. Your modeling skills, you're going to improve. You're going to learn how to import images as trace. You're going to learn how to use a spline tool. You're going to practice working with multiple extrusions. You're going to learn to use the offset, fillet, and chamfer tool. You're going to convert that 3D model for printing. What the heck is Mr. Yurko talking about with these tools? You're going to learn to chamfer things, which means to cut the side off of an object. You're going to learn how to spline, which is when you create a line that best fits a curve through a series of points. So here we have, this is what the spline tool looks like in Onshape. This is a series of points, and this is the curve that best fits through there. You're going to learn the offset tool. The offset tool is super important for us to make things like our cookie cutter here, because we'll be able to take a set of geometry and we're going to make a copy of that and move it. So you can take a look here. I've got a curve. I'm going to make a copy of that and move it in a direction. And it can expand or contract that size. So with my heart here, I can make the heart bigger. I can make the heart smaller. And this is what the button for the offset tool looks like in Onshape. We talked about chamfers. There's another thing we're going to be able to do is called a fillet or a round, which is when we take and we round over the edge of something. The fillet tool when you're sketching looks like this, and the fillet tool for features looks like that. You're going to create a constant rounded edge along something. And as we already talked about, the chamfer is a beveled edge, and this is the chamfer tool. It shows up when you're in the feature modeling environment after you've already closed out your sketch. This pops up at the top, and it's going to take and put a beveled edge on the object that you create. We are going to improve our problem solving skills. We're going to define our problem. We're going to generate concepts, develop solutions, and we're going to construct, evaluate, and of course, present. So how are we going to do that? What's that going to look like for us today? Today, we're defining our problem and we're generating concepts. You're going to be going out and looking up different ideas and coming up with solutions for your project, and you're going to have sketches created. As you generate those concepts, you're going to be working towards developing a solution utilizing Onshape. You're going to pick the best of those and we'll start working them out. Your solution will be developed in Onshape and then converted to an STL format so that we can construct them utilizing our 3D printers. And you're going to we'll print them out and send them home with you so you can go ahead and try them out and evaluate them and then present them to your friends, family, and back to each other so we can determine how good they were. Make sure they're awesome. Your design skills, of course, you're going to practice your concept sketching. That's what you're doing today. You're going to practice your pictorial sketching, making them look realistic. And you're going to practice multi-view sketching, show them in their different shapes. What the heck, math? Oh, yay, math! We love math. So what are we going to be able to do? We're going to be able to figure out what the area of our cookies are. That's going to be important so that we can figure out the volume. That's going to tell us how much material. And we'll use a little bit of conversion. We'll be able to figure out what it's going to cost us not only to make the cookie cutter itself, but we'll be able to figure out what it's going to cost us to use the cookie cutter as we make cookies. Your final product will be a 3D printed cookie cutter that works. So with that said, you guys are going off, being awesome, being yourselves, and developing your own spectacular, better than ever, better than anybody else can produce, cookie cutters. Have fun, and don't forget to be awesome.